Hi folks, welcome to day 5 of Introduction to Statistics. Today what we're going to do is we're going to continue working with the normal distribution, but we're going to take this just a step further and we're going to introduce a couple tools that we can use to be able to identify proportions of a population, okay, by using this curve. And the way we do it is we identify proportions under this curve. Now, the first thing that you have to understand is that a normal distribution is basically a whole thing. You almost have to think about it like a pie chart, you know. Everything is out of 100%. And what we do is we accumulate probability going from left to right. Now, it doesn't have to be from left to right. You can also accumulate from the middle out or from the right to left. But generally, in math, we accumulate values from left to right, okay? So here's what I mean by that is if we start over here, if we start accumulating the space that is under this curve, you know, we would start over here and we would have a very small percentage. And then as we keep moving to the right, the total amount that we accumulate gets larger and larger and larger because we keep accumulating more and more. And because the normal distribution curve is symmetrical, when we get to the halfway point at the mean, we have accumulated half of the proportion. Okay, so 50% or P equals 0.5 or 0.5000. That's at the halfway point, which is the mean. Then, as we keep accumulating, we work our way up to 100% or up to 1. Okay, so like maybe way over here, we would be at about 97% or 0.97 or 975, I think it is. Okay, so that's what we're doing is we're using this curve to be able to calculate. We're using this curve to be able to calculate the proportion of a population up to, you know, and between certain points. Okay, so let's go ahead and jump right in. In order to be able to do this, well, to start, let's review what we did in the last lesson in day 4, and I want you to create a normal distribution that has a mean of 37 and has a standard deviation of 5. Okay. So pause the video and go ahead and create this normal distribution. All right, so hopefully this is what you did. We always put the mean in the middle, so we put a 37 there. Then we go up by standard deviations. So we'll go up by 5. So this will be 42, this will be 47, and this will be 52. Then going downward, we're going to go down by standard deviations. So we're going to go down by 5s. 37 goes down to 32. Goes down to 27 and goes down to 22. Okay, so here is the normal distribution curve that has a mean of 37 and a standard deviation of 5. Now, there's a problem because we can draw conclusions about this particular population, but when you consider the fact that there are an infinite number of possible populations on an infinite number of different qualities in the universe, and that the mean of each population can be a different number, and the standard deviation of each population can be a different number, we can have an infinite number of normal distribution curves. We could have a normal distribution curve that has a mean of 100 with a standard deviation of 7.6. Then we can have another distribution that has a mean of 100.5 and a standard deviation of 8.3. Okay, and those are just 2 examples of an infinite number. So here's the thing: is it makes sense to create one normal distribution curve that can be used to find proportions, and then all we have to do is convert this particular normal distribution curve into the distribution curve, the common distribution curve that's used for all of them. And this has been done, and it is called the standard normal distribution. The standard normal distribution. So the standard normal distribution is almost like it's basically a unit conversion curve that you can turn all. It's like a medium. It's almost like money. You know, I don't know if you understand this. Money is a medium of exchange. It allows you have one thing, and you want something else, but the something else you can't just trade for it. So you sell the thing you have to get money, and then you use the money to get the thing you want. Okay, it's a middle. It plays a middle role. Well, that's kind of like what the standard normal distribution does. Let me show you the qualities to bring it down to how do I do this. The standard normal distribution is a normal distribution whose mean is 0 and whose standard deviation is 1. So, if we were to make a normal distribution that had a mean of 0 and a standard deviation of 1, we would put the mean at the center, 0, and we'd go up by ones. So we'd go 1, then 2, then 3. Then we'd go down by ones, -1, -2, -3. So that is the standard normal distribution. And what we need now is we need a formula, a conversion, almost like converting dollars into euros or converting feet into meters, okay? We're going to convert this particular population with its mean and standard deviation. We're going to convert it into the standard normal distribution. And you'll see why in just a little bit. Okay, and there is a formula for doing this, and you're going to want to write this formula down. And the formula is called the Z formula. So that's what we do is we are converting our units from these units into Z units. So let's say that these units, let's say that this number is a population, and we're measuring how wide, let's say, an opening is. Okay, how wide is an opening? And let's say that this is 37 inches and that the mean opening is 37 inches wide with a standard deviation of 5 inches. Let's say we might be talking about doorways maybe. Okay, so we're going to convert our units from inches into Z units. And Z units are the units of the standard normal distribution. Okay, and we call it a Z-score. Okay, so you don't have to necessarily understand the conceptual side right now. You just have to be able to calculate a Z-score. And calculating a Z-score is very easy. Here's what you do. If you want to know the Z-score of a particular number in a population, you're going to take that number, which we're going to call X, and you're going to subtract the mean of the population. Well, in this case, it's the mean of the sample, but we're assuming it's the mean of the population because we don't actually know the population mean. And we're going to divide it by the standard deviation. So, to calculate a Z-score, you just do the observation the number you're looking at, the number you're concerned with, minus the mean divided by the standard deviation. So let me give you a couple examples here. Let's say that we want to turn 37 into a Z-score. Now, it should be 0, because that's what I'm telling you, is that at the mean, it's 0. Well, let's find out if that's true. Well, let's do the Z calculation. Z is equal to the number 37 minus the mean, and in this case, the mean is 37, divided by the standard deviation, which is 5. 37 minus 37, that's 0. 0 divided by 5 is 0, and sure enough, we get a 0. So now let's look at this 42 right here. All right, what if we did 42 minus 37, because the mean is still 37 and the standard deviation is still 5. 42 minus 37, that's 5, and 5 divided by 5 is 1. And so there you go. All right, well, let's do 47 then. think you can see where this is going. 47 minus 37, that's 10. 10 divided by 5 is 2, and that's 2. All right, let's try 27. 27 minus 37 is negative 10. Negative 10 divided by 5 is negative 2. And so you can see that this z calculation will help you to convert any normal distribution into a common distribution or a standard distribution. So the z is the standard for all normal distributions. And once you know how to turn the values in a population or a sample into z-scores, then you can use a special tool which calculates the proportions under a curve. But for now, the first thing that you need to be able to do for this lesson is you have to be able to calculate a z-score. So here's what we're going to do. We're going to do a few problems where we calculate a z-score, and you're going to need a calculator. You're going to need a scientific calculator or your phone or some kind of calculator. Okay. So let's say that we have a sample and its mean is 17 and the standard deviation is 3.1. And here's what I want to know. What is the z-score associated with the number 19? So x is 19, and we want to know the z-score of 19. So the formula for the z-score is x, that's 19, minus the mean, which is 17, divided by the standard deviation, which is 3.1. So in my calculator, I'm going to calculate this. Now, you got to be careful here. You can't type in 19 minus 17 divided by 3.1, because the calculator is going to do 17 divided by 3.1 first and then subtract it from 19, because the calculator is going to do the order of operations. So you can either put parentheses around 19 minus 17, or you can do what I do, and I do 19 minus 17, and then I press enter, get my number, then I divide by 3.1. So that's what I'm going to do. 19 minus 17 is 2, divided by 3.1 is, this becomes 0.646516129. Now, z-scores are only three digits. It's the first digit right before, well, it doesn't have to be one digit up here, but usually it's 1. Then we have the decimal point, then we have two more spaces, and we're going to stop right there. Well, at least if you're using a z-score table, it's only going to go 2-digit places. Technically, a z-score can go on forever. It doesn't have to stop at 2. But in this class, we're stopping at 2. Now, here's what you have to do. You then have to look at the third digit, and you have to use that digit to round the second digit. Now, because this is a 5, that's going to tell this number to go up by 1. If this number was less than 5, it was 4, 3, 2, 1, or 0, then we wouldn't change this 4 at all. So our z-score is 0.65. That's our z-score. Okay? Let's do another one. Let's say that the mean of the population is 261, and the standard deviation is 33. And we want to know the z-score associated with a value of 220. Okay? So we're going to use our z-score calculation. We're going to do this number, 220 minus 261 divided by 33. Do that in your calculator. I'm going to do 220 minus 261. And I get negative 41 divided by 33. That's going to give me negative 1.24242424. And what that means is I'm going to stop at the negative 1.24. So negative 1.24. And that 4 did not need to be rounded up because the next number is a 2. And so there is my z-score. This is the first thing that you have to be able to do in this lesson. I just want you to be able to calculate a z-score using this formula. And in order to calculate a z-score, you need a number to be calculating the z-score for. You need the mean of that sample or population, and you need the standard deviation. Okay? All right. Let's move on to the next thing that I want to show you how to do. Now, this is a z-table. And for this part, and you need to download this and you need to print it. Okay, I'll put a link for one of these in the description section. Okay, but you need what's called a standard normal cumulative probability table. I call it a z-table. Okay, so once you have a z-table, I want to show you something about this table. Okay. All right, so it looks like this, and here's what you need to understand, is that you have the edges and you have the middle. Now, the numbers that are on the edges, those are called z-scores, okay? Z-scores. And the numbers in the middle, those are called p-values. And what you do is you take the z-score and you use that to go into the middle and find one p-value, okay? And let me show you how this basically works. Let's say that you have a z-score. I think we just did a z-score where we had negative 1.24, okay? Well, watch this. I'm going to turn it into negative 1.2 and 4. Negative 1.24. And here's what you need to understand, is that to get the number negative 1.24 in the table, you're going to find the negative 1.2 on the left side of the table. So if you looked at the table, now there's two sides here. There's this side and this side. On this side are all the negative numbers, and over here are all the positive numbers. Okay? So you're going to be looking for negative 1.2. That's going to be over on this side of the sheet, and on this side of the table. And there's 1.2 right down here. So find negative 1.2. But then the 4 is not on the side. The 4 is going to be along the top. And what you're going to see is if you go along the top, you'll see 0.04. And if you add this plus this, if you added those two numbers together, you would get negative 1.24. So that's how you read a z-table, is you find the first two numbers, whether positive or negative, you find the first two numbers on the left side, and then you find the third number here along the top. So if we wanted positive 2.36, we would find 2.3 here. Then we'd go over to where it says 0.06, and we would go down the 6 column and over the 2.3 row, and there would be a number right here. Now in this case, we're going to go to the negative 1.2, and we're going to go across to here, and we're going to go down the 0.4 to right here, and where those two things match up, let's see what we see in the table. Negative 1.2 over to the 0.04 column, and where they meet up in the middle is 0.1075. 0.1075. Okay? So that is how you read a z-table. Okay? So now I want you to, let's do a few of them together. Okay? What I'm going to do is I'm going to give you a z-score, and then you look in the table and find the correct p-value. Okay? This is the second thing. If you can do this, you're in really good shape. So let's say we have a z-score of 0.86. So now look in the table and see if you can find the p-value for 0.86. All right, so it's positive, so we're going to go to this side of the page, right? And so what we're going to do is we're going to go to where we find 0.8, which is right about there. Do you see the 0.8? And then we're going to go across to the 6, right? So we're going to go over here to 0.06. See that? We're going to go down. And so here, 0.06 to the 0.8 row. And the number that's right there is 0.8051. 0.8051. And so we just turned a z-score into a p-value. Let's try another one. Let's say the z-score is negative 2.03. Let's turn that into a p-value. Negative 2.03. All right? So here's what we're going to do. And you can pause this if you want to, if you didn't quite get it, or you can follow along with me. I'm going to go to the left side here, and I'm going to go to negative 2.0, which is right here, negative 2.0. And then I'm going to go to the column where it's 0.003. So that's the fourth one over, because it goes 0, 1, 2, 3. And then when I go down that column and over at the negative 2.0, I get 0.0212. 0.0212. Now I want you to know the way I would write this. Actually, I wouldn't put that 0 there. I would say that p is equal to 0.0212. That's what I would write as the p-value. That's the way that I do it. Okay? Let's do just one more, and then I can teach you the third thing that I want you to learn. Let's say that the z-score is 1.48. And why don't you turn that into a p-value? Pause the video, go. All right, so I'm going to go to the 1.4 column, which is on the right side. It's positive. I'm going to go to 1.4 right about here. Then I'm going to go to the column that has an 8 at the top, and that's all the way over here. And when I go down that column and over the 1.4 column, I get 0.9306. 0.9306. It's that easy. Okay? Now on the worksheet that I have for you, you're going to calculate a bunch of z-scores at the top of the page, or in the kind of the top part of the page. Then the bottom part of the page, you're going to calculate, or you're going to look into. You don't have to calculate these. You're just going to take a z-score and find a p-value. And now I'm going to show you the third thing that I need you to understand. I need you to be able to identify you need to be able to identify a less than proportion given a z-score and a z-table, a more than proportion, and a between proportion. So let's say that you were asked, what proportion of observations in the standard normal distribution curve are less than z equals 1.35. So here's what you do. You have to turn that into a p-value, go in the table, 1.35. And we're going to go to 1.35, and we see 0.9115. 0.9115. Now here's what I need to tell you about this z-table. All of the probabilities, all of the proportions that are in this table, all of them are less than proportions. They are all less than. So these answers that are in the table are all less than answers. These z-scores tell you the proportion under the curve that is less than that number. So if we went to 1.35, that's right about here, 1.35, because this is 1 and this is 2. And the 1.35 is between 1 and 2. And this is the mean, that's 0, right? And so what I'm saying is that this table is telling you the proportion of the curve that is less than this spot, 1.35. And that answer is 0.9115. And so because this table gives you less than proportions, if you are asked for a less than proportion, then the number that you get out of the table, that is your answer. Now let's do a more than proportion. What does more than mean? Well, let's say we wanted to know what proportion is more than z equals 1.35. Well, more than 1.35 is not on the left side. The left side is less. Left is less. The right side is greater than. The right side is more. So what this is asking is, if we want to know what proportion is more than z equals 1.35, we want to know this region right here, this proportion, greater than 1.35. And because the proportion of the whole thing is equal to 1, then what we do to find the proportion above 1.35, if 91% is less than, then how much is more than? And remember, I said this is like a pie chart. If 91% is less than, then 9% is more than. And the way I got that is by subtracting 91% from 100%. 100% minus 91% is equal to 9%. And so what you're doing here, but now we're not going to use 100. We're going to use 1 because we're putting our answers in decimals. So to find a more than proportion, the first thing you do is find the p-value from the table, 0.9115, and then you do 1 minus the p-value. So we're going to do 1 minus 0.9115, which is 0.0885. 0.0885. And that is our p-value, our more than p-value. This region in here is p equals 0.0885. That's how you do a more than proportion. And now let's see, how do we do a between proportion? Let me get rid of all this. You may have to rewind and write that down because you weren't expecting me to erase that. So to do a between proportion, you have to have two z-scores. So let's see, we want to know between z equals negative 1.32 and positive z equals 0.65. Okay, so here's what we need to do. We need to find the p-values for both of these numbers. So the first step is find two different p-values. Why? Because you were given two different z-scores. So let's find the p-value for negative 1.32. It's 0.0934. 0.0934. And then the p-value for 0.65 is 0.7422. 0.7422. And now all you have to do is subtract the two p-values. Subtract the two p-values. Basically, you're doing the larger one minus the smaller one. So we're going to do 0.7422, 0.7422 minus 0.0934, and we get 0.6488. And that is how you calculate a between proportion. And that's all I have for you in this video. I hope this helped you a bit. If you have any questions, come to me, and I'll see you in class.